Alright, what we're going to do, we're looking at the diagrams of the 3D shapes, okay? And the dotted lines we use to show the edges that cannot be seen. When you look at the shape, from one side, what we got to do is we got to name the shape. We got to figure out how many faces does it have, the number of vertices. Now, vertices is a corner, okay, where basically where two lines meet, two or more lines meet, excuse me. And then basically the number of edges is basically the number of straight lines, okay. So we'll start off with the cube, okay. The name of the shape is a cube, and cube has number of faces. It has 6 faces like a dice, okay, because a dice is a cube. And then we have to go number of vertices. Well, we can see 1, 2, 3, 4, 5, 6, 7, 8. 8 corners basically, right? And then number of edges, which is slightly more difficult, is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 edges. Who got 10? 12. Which two am I missing?
Top right.
The top right and the bottom left.
Oh yeah, sorry. Bottom left and
top right.
Top right. Yeah. So 10, 11 and 12. 12 edges. Okay. Next one, cuboids. Name the shape is a cuboid. Okay. Okay. Cuboid, basically number of faces it has 6, exactly the same as cube. Number of corners 8, number of edges 12. It's pretty much exactly the same as the cube. Next one is the what's it going to be, a pyramid, okay? So a pyramid, and the pyramid has number of faces 1, 2, 3, 4, 5. 5 faces. It's going to have number of vertices, number of corners, 1 corner at the top and 4 at the bottom. So that's going to be 5 vertices. And then the number of edges, well, there's going to be 4 edges on the bottom, Kane. 1, 2, 3, 4 on the bottom. And then there's going to be the 4 diagonals. So it's going to be 5, 6, 7 and 8. 8 edges. Okay, everybody got that right so far?
Tetrahedron.
A tetrahedron, yeah, that's another way of saying pyramid, yeah. Tetrahedron, yeah, that's okay. Now, okay, next one is, this is what's called a triangular prism, is what you can call this one. Okay, now a triangular prism is basically, the reason why it's a prism is it has the same area going all the way through. What we're doing here is, okay, triangular prism. Now it's basically, it's a reason why it's a prism is it's like a slice loaf of bread. You can cut it into the same slices over and over and over again. That's how you identify prisms usually. Okay, prisms have 2 things. They have sharp edges, so no curves, and they're basically like a slice of bread. They can be chopped up into the same area over and over and over again. Now, for this triangular prism, how many faces does it have? 1, 2, 3, 4 and 5. Okay, how many vertices does it have?
6.
Yeah, it looks like 6, alright. 1, 2, 3, 4, 5 and 6. How many edges does it have? 9. Okay, we'll see about that now. 1, 2, 3, 4, 5, 6, 7, 8 and 9. So that's 9 edges, okay? So lads, just try and picture it out if you can. That's the best way. Now, number 10 is number 10. Which 3D solid is made from the following nets? Well, A is definitely a box, because you fold that up, so it's going to turn into something like this, a cuboid or a box, yeah. So just make it like this. When it folds up, what's going to look like? It's going to look like something like this. There's the hidden corner, the hidden edge, if you will, and there's the other edges there. So that's what it's going to fold up into. Okay. The next one is, I think it's going to turn into a it's going to turn into a triangular prism, okay? So if we, sorry, not triangle, it's like a pyramid with a triangular bottom, okay? Sorry, did anybody get, lads, what's going to happen here is the faces fold on each other. Connor, the faces fold up, okay? And what happens is you're going to basically get a triangular bottom, which is this here on the bottom, okay? And if I was just to distort that a little, and then basically if I join up to the top, that's what you're going to have. You're going to have your three edges like that, okay? So it's a triangular, okay? So triangle on the bottom, three triangles at the sides. Now, what's going to happen next is, and it's called a tetrahedron. The next one is a what, guys? You know it well. It's cylinder, okay? It's going to be a cylinder. So what happens is we fold this part up like so, and that makes the curved surface area. And then the two circles, top and bottom, they're going to make your the top and bottom of your cylinder. So it's going to look something like this, basically. So that's it there, okay? So that's your cylinder. Alright guys, next one. Find the surface area of the nets of the solids below. Take pi to be 22/7. All dimensions are in centimeters. Okay, let's start off with the cuboid, okay? Just make it a bit bigger. Now, let's find out about this. Can anybody tell me what is the... Sorry, does it give you the height of the surface area of the nets? Now, does it say 4x4? They're the same size?
Yes.
4, so that's 4 as well. Okay, what size is this one here? This box here? It's going to be 4x4, which is 16. This one here?
32.
32. The other box? 16, or the other square. This one here?
42.
32. 32. And 32. Add them all together, what do we get?
160.
Sorry, what is it actually? Because it has to be an even number. 160, thank you, sorry. 160 centimeters squared, because it's area. Okay, next one, guys. The next one is more difficult, and I'll explain why. The next one is a triangle, okay? And to get the area of a triangle, what do we need to know? We need to know either one of two things. We can do this two ways. We know that it's 6, 6, and 6. We don't know the vertical height. Okay? Sorry, Ken. We don't know the vertical height. Now, we can do this two ways. First way is we do Pythagoras' theorem. We cut this in half and we find out what is the height. I'm going to do it the second way this time, because we haven't done the second way in a while, just for revision's sake. Does anybody remember the S formula? S equals A plus B plus C all over. We just double check that. Is it over 2?
Yeah.
Okay. And then the area equals the square root of, what is it?
S by S minus
S by S minus A, S minus B, S minus C. So look, we'll do with that method. It's easy, okay? Now lads, in this question here, what's A, B and C? They're all 6. So S is 18/2, which is going to be 9. Now that we know that S is 9, what we're going to do here is this. 9 bracket 9 minus 6, 9 minus 6, 9 minus 6. Put that into your calculator. It's going to be 9 multiplied by, it's actually going to be 9 multiplied by 9, but we'll put it in. 6 minus 9 minus 6, 3. 9 minus 6 again, another 3. Actually no, it's not going to be 9, it's going to be bigger. 3 again. The answer is 9 root 3 is the area. 9 root 3 centimeters squared. Who got that out?
You don't have to do that.
Sorry?
You didn't have to do that. 7 back to 36.
Oh yeah. Give me a second, Connor. And what we're going to have to do here is, that's only one triangle. How many triangles do we have? 4 of them. So that's what Connor was saying. When we multiply this by 4, we're going to get 36 root 3, and that's the correct answer, is it?
Yeah.
Yeah. So that's remember, it's not just one triangle; it's 4 of them. Okay. Kid. I got to remember. I got to show you another way of doing the same question. Right now, that way is quite good. That all you have to do is use the formula. And there's very little that can go wrong with it, but it does take slightly longer. Now, the other way of doing this, remember our answer is 36 root 3. The other way of doing it would have been this. Now, what gap? Yeah. Lads, this one here, okay, what we said earlier was, if we make a right angle triangle out of it, what we can do is we can cut it into half. So it's going to be 6, 3, and Gavin, x is going to be the opposite side. So what you'd have to say is 6 squared equals 3 squared plus x squared. That's going to be 36 equals 9 plus x squared. We then know when we bring over the 9, changes to minus 9, we know that x squared equals 27. X therefore is the square root of 27. Now that's the height. Now to get the area of a triangle, it's a half base multiplied by height, which would have been a half 3 times the square root of 27. Okay? So if we put that into the calculator, a half 3 by root 27. Okay, a half 3 by root 27. What we'll get here is once again our so what's that? 9 root 3 over 2. Now,
That's for one.
sorry?
That's for one triangle.
Yeah, but when you multiply by 4, it doesn't work out. Just want to check this again, guys. Oh, that's it. Sorry guys, it's 6. The base is not 3, the base is 6. Because the base is all the way across, so that's Connor's dead right, that's what happened there. So it's going to be 9 root 3 centimeters squared. Once again, multiply that by 4 and you get 36 root 3 centimeters squared. If you're comfortable with Pythagoras' theorem, do it this way. If you don't like it, you find you make easy mistakes, do it the other way. The other way is longer, but less mistakes are made. Now, what we're going to be doing next is we're going to be going for the surface area of the cylinder. Okay. Now, the radius of the cylinder is 7. The reason I know that is, the radius of the circle is 7, because I know that. Okay, guys, I know that the radius here is 7. Okay. So what I'm going to do is, I'm going to get the area of the 2 circles. The area of the 2 circles is pi r squared. 22 over 7 multiplied by 7 squared is going to be 154 centimeters squared. That is for both circles. Then I'm left with a rectangle in the middle, which is 44 multiplied by 20, which is going to be 880. So the rectangle is 880. Add them together. So 880 plus 154 plus 154. That's 308 plus 880, which is 1,188. Okay, centimeters squared. All right. Next one is we're getting the volumes. Now I only have to get the volumes of A and C. I actually would need a specialised formula for B, which isn't on our course. Okay. So A is length by width by height, and as discussed earlier, it's a box. Okay. So its length is 8, its width is 4, and its height is 4. So 8 by 4 by 4 is 8 by 16. 8 by 16 is 128 centimeters cubed. Okay. That's for the volume of a box. Okay. Now the next one's the volume of the cylinder. Now this one's a problem. I'm going to tell you why there's a problem with this one. Okay. The problem is with the cylinder is when they unravel it. Actually, no, it's not a problem. So excuse me. What happens is you have our cylinder here. Okay. We have the cylinder here, and what happens to the cylinder is its radius is 7 and its height is 44. So it has a radius of 7, a height of 44, and we're just going to do pi r squared h. That's going to give me 22 over 7 multiplied by 7 squared, multiplied by 44. Will somebody tell me what that is?
It's not 44, it's
Height's 20.
Oh, sorry, the height is? Oh, sorry, the height's 20, excuse me, you're right. 44 was the circumference, actually, of the, if you go the far way around, that's what it is, you're right, it's 20, sorry, excuse me. Because the, it's a sideward cylinder, okay? So, what is it? 3080 centimeters cubed. Okay guys, that's the end of that question. Anybody get that one right?
Yeah.
Okay, good. Next one. Number 11. Okay, the following net has a 3D shape of volume 2512 centimeters cubed. Name the 3D shape. It's a cylinder. Okay, part 1 is done. Okay. Next one, taking pi equals 3.14 and given both identical circles have a diameter of 20. A diameter of 20 means a radius of what? 10. Okay? Calculate h and x, the dimensions of the rectangle. Next one is, do you want me to find out what is the height of the cylinder, okay? So what you need to remember is volume of the cylinder is pi r squared h. Pi r squared h is 2512. Pi, it tells me, is 3.14. Radius squared is 10 squared. And the height, I don't know what it is, okay? So what I'm going to do here is multiply this out. I'm going to get 314h equals 2512. It's multiplied by 314 on the left, which makes it divide by 314 when I send it to the right. So 2512 divided by 314. Yeah, it's going to be 8. 8, okay? Height equals 8, which is great. Now, what you really need to remember is, do you see x here? Okay? X is the length 2 pi r. It's basically the same length as if I cut the circle open. That's the way the cylinder is formed. It has a rectangle which is the same length as the circumference of the circles. So x is equal to 2 pi r, and that means x is going to be equal to 2 multiplied by 3.14 multiplied by a radius of 10. Kane, what you get for that?
Putting the calculator.
Yeah. 62.8? That's what I'm looking at. What do you think?
Yeah.
62.8 centimeters.
62.8.
Yeah. How many people got that? Just Harry, was it? Right, Luke. Grant. Okay, Brian. Yeah. Okay, last one. Last one, guys. That's next one, number 12. Now, number 12 is it's basically going to be a trapezium, okay? Find the volume of the prism solid at a given net. Now, if I was to draw the front of this, if I was to draw the front of this, it looks something like this. Two lines that are parallel to each other, and then, parallel. Two lines that are parallel with each other, and then there's going to be two parts like this, okay? That's what the front of it looks like, okay? Now, if I was to replicate that again, and if I was to clone it is another word, when you replicate something exactly like itself. Sorry, 1 second. So what I'm going to do is I'm going to draw the box that's going to be formed from this net, okay? Okay. So that's it there, okay? Now, all we got to do next is link them up, and what's going to happen is this is your object here. It's basically the same as a normal box, except the front of it isn't square or rectangular shaped, it's trapezium shaped. Now, you remembered one of the first exercises we did was, if we want to find the volume of this, also what we need to do is find the area of the face. If we find the area of the face and multiply it by the length, we're sorted. So volume equals area of face multiplied by length. Now, it's a trapezium. Can anybody tell me the formula for a trapezium? Okay, a plus b over 2 times h. Now, let me explain what a plus b over 2 divided by h is. Okay, so it's going to be a equals a plus b divided by 2 multiplied by h. Okay, what a is the top length. Does anybody know what the top length is? There it is there, the 7. We're folding this in, and I'm folding this one in. That's making this blue side. This one here is the blue side, and this one here is the red face. Okay? And then on top, okay, this part here is the green face, which is here. Okay? The black face is the base on the bottom. Okay? And then the two side faces, which is going to be the two, I'm going to make them both purple, is basically this one here and this one here. That's the two purple sides, okay? So, just getting rid of all of that, what we need to do there is we need to figure out which one is which, okay? Now, lads, it's 7 on top, and what length is it on the bottom? 7 on top, 22 on the bottom. What's the height from the 7 to the 22?
8.
From the 7 to the 22 is 8. And what's the length? The length is 35. Now you have everything you need. So the area is a plus b, which is going to be 7 plus 22 divided by 2. And it says that the vertical height is 8. So you just got to put that into the calculator exactly as it looks. Sorry, I'll just put brackets in first. Brackets, then press the fraction button. 7 plus 22, which is 29 if you just want to put it in that way. Close bracket, and then multiply it by 8. And what you're going to get there is 116. The area is 116. Now area of that face is not the volume. We're looking for the volume. So we're going to have to multiply that by the length, which is 35. So volume equals 116 multiplied by 35. And what do we get there?
4060.
Sorry?
4060.
4060. Volume is 4060 centimeters cubed. Did anybody get that one?
No.